serverless is becoming a very common pattern because of its power. I thought today that what would be interesting would be to talk about what you can do with serverless, not just for toy applications, but actually for more broad use cases where you might be wanting to take an application that already exists and refactor it. Maybe not the whole thing, but because that would take a really long time, and entire refactors of applications never go well. But maybe instead, what if we could pick apart and refactor bits of applications that would give us some benefit? So I'm going to share my screen here, and we'll pop over to a short presentation just to kind of tee things up. Of course, I'm sharing the wrong screen. I apologize. Let me switch this over. There we go. All right, so real quick, my name is Chase Douglas. I'm the CTO and co-founder at Stackery. Stackery is a platform that helps our customers design, develop, and deliver modern applications on top of AWS. And while we've done that, for people building new applications, we've also done this for people building lots of refactored, modernized apps. But let's take a step back and as this is the serverless edition of Bash, let's focus on why serverless is a thing in the first place. Businesses, they need to build applications to help their customers achieve some kind of benefit. But what we build is very different from how we build it. No one actually cares about the plumbing that goes into how the applications are constructed. Serverless itself, if we try to define what it looks like as you're building an application that you don't have to waste all your time working on the plumbing, it does actually look like a bunch of plumbing. It's often made up of lots of different services that talk to each other, although in this case, the services are taken off the shelf from AWS, your cloud provider, to manage authentication, to manage your database tier. But the key is that it's very microservice-like, and so you have to have mechanisms to manage that. The other side of serverless is that it's this form of a collection of managed services. So of course, you're not dealing with servers that are running in racks and data centers. Instead, you're dealing with these individual components of an application, that's software layered on top of those servers in the data center that you don't have to manage yourself. So there's kind of this array of a couple dozen services that people are very commonly associate with serverless. These are Lambda for functions as a service, SNS as a pub sub topic, SQS for queuing, API gateway, DynamoDB. These are all abstractions that you can take and ask the AWS to provision for you, and you don't have to manage the day-to-day operations of. The other side to serverless is that it's a mechanism to really match your utilization to what you pay. So if we think about in the long past, maybe not the past for some of you, but dealing with data centers where you have to manage individual servers that are racked. And there you have to really pre-plan and pay for the capital expense of buying servers before you need them, hopefully. And so if you're buying these servers before you need them, you're always having these upfront costs that are shown in purple here that you don't get any benefit out of. But instead, if you could track the utilization as you go, that'd be a much more ideal scenario. In fact, we could step through what this really looks like as you get more and more closer to a serverless position. So here, the red line is what you have to pay to rack physical servers in a data center. The blue line is what your actual demand is. And this could be over, I guess if this is servers, this is probably over the matter of weeks or months. But as we get closer and closer towards a serverless stance, let's say we move to the cloud, and now we have the ability to, with some API calls, manually provision servers up and down. Maybe our time series here, our time axis is, over a period of, days or even hours. We can manually spin up servers and tear them down, but we're still just kind of approximating demand. So there's still a decent amount of cost between the blue curve, our utilization, and the red jagged curve, which is what we're actually paying for. Maybe we start to throw in some auto-scaling algorithms that get us closer to meeting need exactly when we need it. But serverless itself, you literally pay for just the usage at the moment that you're using your resources. So you pay for the number of milliseconds that a function is running in response to one API call through API gateway. This gives you a huge amount of flexibility and helps you meet your cost, helps you meet your goals for tracking cost utilization. By doing this, you not only help potentially your production environment, but you actually help your overall total cost of operations. So as an example, Joe Emerson is someone who's built a startup for the insurance industry fully on serverless. And they're a happy Stackery customer. Their April AWS bill is just under $740. He broke that down. It's really interesting to see what their numbers are like. But what's important is that at the stage of a company that he's at in the past, pre-serverless, he would have easily been around $15K per month in AWS spend because of all of the development and testing environments that would have been spun up to similar capacities as production for proper testing. With serverless, you've got the ability for individual developers to spin up their own environments, but they'll cost you pennies to run because developers don't need to hit things with high throughput to test functionality changes. But serverless isn't just for greenfield applications, new startups, or new projects that a company is taking on. You can use it to refactor modern applications. This is what MasterStream, that's a company that's done a top to bottom refactoring of one of their applications. They moved from the data center into the cloud first, and they got the elasticity gains, being able to spin up servers on demand, tear them down, but their costs really shot up versus what they were paying on the data center. But then once they switched to a serverless approach, they actually ended up saving 90% on their AWS bill, and they got much faster in developing and shipping their software. But it's not all, it's not the easiest thing in the world. There are challenges to modernizing applications. There's with the old approach, you've got cost and scale problems for monolithic applications. You've got challenges with cost and agility of your development team. And you've got, if everything's a monolithic app and one route is really problematic, it has the ability to take down the rest of the application depending on its failure mode. There's a lot of great reasons to move off of a monolithic app and modernize it, but it is hard. You have to figure out ways of redoing your deployment mechanisms. You've got mechanisms that you have to figure out for, as you scale, both in terms of throughput, but also in terms of the size of the application. How do you factor that out into more and more services that are being managed by your service provider? Lots of challenges in this area. but there are key known mechanisms for doing this well. So if especially your application is an API service, a RESTful API, you can start to use API gateway as a proxy layer to pick off individual routes to refactor one at a time. And if you've got the right tooling that helps you manage this, you can actually do this very quickly. And that's what I'd like to show today. We're going to jump into a little bit of a demo. Let's imagine that we've got this two-tier application. It's old school .NET framework running on Windows servers in a data center. And we want to jump to modern serverless approaches for updating this application. It's a simple application. It's got a library with endpoints to catalog your books and your authors, but maybe the books route doesn't scale well. So what can we do to make this serverless? So I'm going to hop out of my presentation now, and let's take a look at what this application looks like. It's running inside of AWS, at least at this point. We lifted and shifted. We're using Elastic Beanstalk, which is kind of like AWS's version of Heroku. And I can hit this route, and don't worry, everything is fine. I just don't have anything at the root route. And we can see this API books route that is coming up. Comes up in traditional XML that Garth loves so much. So let's imagine that we want to take this, which is running on Elastic Beanstalk on virtual servers, and we want to move it into a serverless type of environment. Well, I'm going to hop into VS Code here, which is my favorite IDE. And I've got a project, kind of a blank project. It's got a blank CloudFormation or SAM infrastructure as code template that many of you may be familiar with. For others who aren't, it helps codify our resources that we're going to spin up. And I'm actually going to kind of do a split screen thing here and show what it's like to build up a CloudFormation template using Stackery here. So first, we talked about creating an API as a proxy for our existing API. And so if we hop into here, let's imagine we are going to first create a default route that will send everything that doesn't match what we're going to implement to the existing API that I've got. And then let's come into here. Let's take any method that hits API books and any method that hits /API/book/star in here. All right, so I'm starting to make some endpoints. I'm going to proxy, oops, I opened up the wrong one, proxy my default endpoints over to my existing API. So we'll copy this link address, put that here. All right. So now I'm proxying that. We can see that we're building up this CloudFormation template over here. The next thing is we want to re-implement those books routes. So let's drag and drop a function here. We'll call these books, and I'll put those in my books path. And this will be a .NET Core 3.1 function. Yeah, looks like I had some leftover stuff. Well, all right, so now I can start to wire up my routes. All right, I got my books routes going to this books function. And then the last thing is this talk to a SQL Server database. So I'm going to drag and drop a database, but instead of creating a new nice Aurora serverless database cluster, I already have an existing database. So let's find out where that database is. I've got that open here, and here's the ARN of it. Where's that ARN? I swear I'm in the right tab. Here it is. And I'll copy and paste that. put that down here. So I'm using an existing database instead of creating a new one. And I'll wire up my function to it. The last step that I need is I've got to have some credentials to connect to this database. The best place to store those is inside of AWS Secrets Manager. So I have them stored there already, and I'm going to drop down and grab a secrets resource here and wire that up. By wiring this up to my function, I've done a couple of things. I have added in permissions so that I can access the database secret inside of Secrets Manager. And I've created some environment variables here that give me the DNS address of the database and the secrets are in the port of the database somewhere in here. Yeah, the database port. I've got a location for environment-specific secrets namespace that I'll use. So I've kind of constructed this template here to create my application. And then the next step is I gotta write my code and port that over from my .NET Framework application. So what I'm going to do here is I'm actually going to pull up, and because this is a limited time engagement, I'm going to pull up what I've already built here in GitHub, just to kind of show what this looks like. So I called my function web API here instead of books, but I copied over a bunch of the .NET application stuff from my .NET framework. I was able to copy over my book model wholesale from .NET framework into my .NET Core API, same as my authors model. I'll actually zoom in a little bit. I had to update a bit of my books controller, switching from the older .NET framework approach to .NET Core. So how they specify routes is a little different there with decorators, which makes things a little bit easier. So I was able to port most of the code. About 90% of this code stayed the same, and just about 10% changed. So it wasn't too bad. And lastly, controllers and data here. I updated the code to connect to my SQL Server database to get the database password from Secrets Manager. So here I've got a new Amazon Secrets Manager client. I asked to get the value of a secret in my environment, which might be /prod or /dev /db password. And once I got that that secret value back, I'm able to grab the password from it, get the database address and port for my environment variables, and create the connection string for the .NET framework. And so I put that into my source code and I deployed it out. And what we see here is a deployed version of my application. Apparently I came in and accidentally deployed in this random function2 resource. But leaving that aside, I've got this staging URL to play with for my application. We can see that I'm already starting to proxy the existing non-existent root route. But if I hop into /API/books, we'll see, because this is .NET Core, it's got a different default behavior of returning in JSON instead of XML. Sorry again, Garth. But we're already, using this .NET Core Lambda function to serve our responses in a more scalable way, alongside, say, the authors route, which we did not port over and is still in XML. So this is, really kind of hopefully giving you a sense of a pattern that you can use. If you're saying to yourself, I'd really love to use serverless, I've played around on the side with this, but even though there's benefits that in theory could be utilized at maybe my place of work, where we build older style applications, I can't figure out how I could bring serverless into this. Hopefully this gives you a sense of some mechanisms that you can use as tools to help you pick apart and re-implement little independent modules, API routes of applications, one piece at a time to build in a serverless direction, hopefully giving you benefits of scaling better, lowering your cost, shipping features and functionality faster, all the great stuff that comes with serverless applications.